Hi, welcome to another tutorial. This tutorial is very important and very widely accepted, which is software testing. So I will discuss about throughout this about the software testing, different approaches to testing, and the testing is very acceptable, and no manager and no one wants to oppose this. So in every software house, in every company, whether it is large or small, so they realize the importance. They do testing, they do software testing. Sometimes testing is confused with QA, quality assurance personnel, and quality assurance personnel is usually a broader term which usually people relate with software testing. So we should not confuse software testing with quality assurance. So in software testing process, we execute the product, we observe the failure of application by running it. So let's move next and discuss about where it resides in our quality policy. In broader perspective, we have quality management. Quality management covers all the department in organization. That can be HR department and human resource department and marketing department, quality assurance, software development. All the departments are under the quality management. So the quality company has quality policy, and in this quality management system there is quality assurance and quality control. So in quality assurance we usually have separate team, quality assurance team, which reports to CEO. So in quality assurance we have, under the quality assurance we have quality control team, which is usually called the QC, and usually testing resides in this domain. So purpose of software testing is to control the quality, whereas quality assurance QA usually does then improve the processes, monitor the processes, participates into larger perspective, improving the quality. So they kind of ensuring the quality. They are broader when we talk about the quality control things. So let's discuss all these about. In this section I will discuss about what is testing, why testing is necessary, 7 testing principles, test process, then psychology of testing. So common perception, as I told you, testing is limited to execution. A test activity exists and before execution as well. So other activities through their software development life cycle. So testing starts through the software development life cycle when we gather the requirement, when requirements are documented, then test cases are prepared. So testing starts when requirements are written, and it continues when even the application is deployed to live server. So testers contributes to review. Testers have great contribution in review processes and walk through inspection, all these activities. So another concept which we have, test process. We plan our test cases, we design and execute our test cases. So testing should be planned. There should not be ad hoc testing, because ad hoc testing depend upon people's, and people make mistakes and there is no check and balance. So things go in wrong directions. So we should plan, everything should be planned, control, monitor. So test is a process which should be optimized. We cannot optimize this process when we cannot control it. So I will discuss this test process, and detailed discussion will be next about how to do test planning, design and execution. So let's discuss about the objective of testing. Testing is all about finding defects, so gaining confidence about quality. So purpose of testing is uncover most of the defects, because we want our product bug free, almost ideally bug free. So it provides information about the quality, so it prevents defect. So testing purpose should be to prevent defects. We should gain the confidence, we should prevent defects, we should learn the lesson so we can improve this process. So test, it evaluates our work product, it verifies that all requirements have been met, so we should confirm the requirements. It reduces level of risk, because without testing there is so much risk involved, because if we are no testing in place, then can be possibility that things are missed and client will get, and there will be embarrassing for the development team. So it complies with the contractual, legal, regulatory requirement and standards. So as a tester, make sure that our software product complies the regulatory requirements and it meets all the necessary standards which are required. So in companies, usually we have legal teams to quality assurance person coordinates with legal team to make sure that all legal requirements are met. So when we talk about testing, we generally classify it into dynamic testing and static testing. So in static testing, we usually do informal reviews, walkthrough, technical reviews, and inspection. So inspection is more formal review. Usually we also mix formal and informal review to get the benefit of both the worlds. So in dynamic testing, we have product available, so we run the product, we observe its performance, we report the issues. The internet testing is best suitable for performance issue, for the issues for which requires users functionality, non-functionality points. So when we talk about the level of testing, there are unit, integration, system, user acceptance testing, and non-functional testing. So in this level, unit testing usually is performed by our development team who writes the code, and integration testing, system testing, user acceptance testing is performed by quality assurance personnel, and usually user acceptance testing is performed by our client. So client decide whether it is okay or not. So now let's discuss about why testing is necessary. So having tester involved in the requirement review as user story refinement could detect defects in these work products. So they are best candidate because they are quality trained people. Testers are usually companies require ISTQB certified testers, so they know about the quality. Say though they have experience and knowledge, they have different mindset to approach the product. Usually they have kind of breaking approach, destructive approach. So in this way we can improve our product. So having tester work closely with system designer while the system is being designed can increase each party's understanding of design and how to test it. So I have already told you the difference between quality assurance and quality control. So we should start from, we can approach in two ways to our quality policies. First of all, in broader perspective, company wise quality policy, then we have quality assurance, and then we have quality control. So we should aware these terms about quality assurance, quality control. So we our discussion are about defects, failures, errors. So our purpose is to reduce defects, so our application can run without any crashes or strange results. So it is time to let's discuss about what is error. Error is a mistake. Human make mistakes, that human action that produces an incorrect result. So another, we have fault, defects and bug, a manifestation of error in software. So it also known as defect or bug. if executed, a fault may cause a failure. So failure is deviation of software from its expected delivery or service. As you can see from this picture, a person make mistake and an error. So I will discuss about there can be many causes of errors. So person makes and then it creates a fault in the software. Then its fault is not detected that is there. So testing purpose is to remove that, to detect that fault and remove. If fault is there, then there will be a action that can cause a failure in operation. So in this case, if the application has faults, and that fault will cause the failure in the application. So there are many causes of defects. For example, error may occur in many reasons such as time pressures. If human, software is a human intensive activity. So time pressure, when given too much time pressure to our human resources, they will make mistakes. And humans are error prone. So another point which is cause of software defect is inexperience and insufficiently skilled project participants. If our project participants have no skills that relate to specific project, then definitely insufficient skilled people can cause software defects. Miscommunication between project participants, including miscommunication about requirement and design. If there is no proper processes in place for communication, there can be miscommunication between the teams. So miscommunication is a problem, and we should fix that problem. Usually in this world, your teams are doing remote work, and so we should improve our communication process. We should make sure that teams are cohesive, they communicate properly. They do usually most of teams are in agile, and they usually do daily scrum meeting. They usually cooperate with each other, and there is no clashes between quality assurance and testing professionals. So another one is cause of failure is complexity of the code, design, architecture, and underlying problem to solve, technology used. So if there is code is very complex, architecture is very complex, so this is possibility that our software will be buggy. Misunderstanding about intra-system and inter-system interfaces, especially when such intra-system and inter-system interactions are large in number. So if system is huge and developers are new, they don't know the inter-system and intra-system interconnection, they know how API works and how business logic works, and so there are no domain specialists involved which guides the development team and testing, so there can be problem in the software. New unfamiliar technologies, if our developers are not familiar with technologies, we should train our resources, management should involve in this process. So these were some of the causes of software defects. Now let's discuss very important topic you will come across in any discussion, in any testing discussion. These are very 7 testing principles and very important. You should remember all these. So let's see. Testing shows presence of defects. This is principle number 1. And principle 2 is exhaustive testing is impossible. Principle 3, early testing. Principle 4, defect clustering. Principle 5, pesticide paradox. Principle 6, testing is context dependent. Principle 7, absence of error fallacy. So let's discuss little bit about these testing principles. So first one was testing shows presence of defects. Testing shows presence of defect, not their absence. So testing shows usually error of commissions. In error of commissions, we show what wrong is done. So in testing can show that defects are present in the system software, but no matter whatever count of defects are found at any point of time, we cannot say there is no more defects. In testing, if we have reported so many bugs and we are confident that there is no more bugs, then there is possibility when that product is given to client, the client may reject because it does not fulfill the client needs and requirement. So problem can be there in requirements are not properly understood, and so this point is all about that testing shows if there are problem, then we can discover in testing, but it is not showing that there is no defects present. So their absence cannot be shown in testing. Also, to add to it, in case no defects are found, it is not proof of correctness. So in principle 2 is exhaustive testing is impossible. This principle says that testing everything, which means all possible combination of inputs and preconditions, generally not feasible to be conducted. As an alternative to exhaustive testing, we usually do risk testing. Priorities should be used to focus on testing effort. So here is an example. For example, in our web form, we have 15 input fields, and each field takes 5 possible values. Then to test all valid input value combinations, you need 5 raised power 15 tests. So we don't have that time to test everything, even in this small page. In large application, we have so many fields and so many test cases, scenarios, so testing everything is not possible. So this is that exhaustive testing is not possible. To overcome this problem, I will discuss further. We use boundary value analysis, we use partitions. So I will discuss how we can solve this problem. So let's discuss about early testing, principle 3, which is early testing. So testing should be involved early. Testers should be involved in early when our specifications are prepared. So they should be involved, testers should be involved, quality assurance professionals should be involved in specification, design, code, and test and release. So as early as possible they should be involved, because bugs which you caught earlier are easy and cost effective to fix. If bug is found later, when product is used by client, there can be catastrophic results, and there can be many, it can be most costly. And cost, here I cost mean the cost can be in terms of dollars, in terms of human life. If our application is safety critical, so there can be cost related to reputation, there can be bad reputation in the market. So its company don't want to do that. They should establish a good relationship with client. So if we want to establish good relationship with client, yeah, definitely we should give good product, quality product to our clients. So principle 4 is defect clustering. Usually the 80-20 principle, which is very generic and which applies to software industry also. So this principle shows that 20% modules have 80% bugs in it. Mean the bugs which are more complex, the modules which are more complex, and most of the bugs relies into that module. So 80% bugs they are in our 20% modules. We should take care of those modules. We should give extra attention to our modules which are very complex, because complex modules usually have defect clusters. We should identify and we should fix. Usually some applications have one page which is very heavy and very widely used. For example, in human resource information system, there can be new hire page, and we should test it thoroughly. And so now let's discuss principle 5, which is pesticide paradox. So this says that if the same tests are prepared over and over again, eventually the same set of test cases will no longer have to find new defects. So to overcome this pesticide paradox, test cases need to be regularly reviewed and revised. So if you are executing same tests again and again, then definitely these tests will not be able to find new bugs. Testing is creative activities, and we should think differently. We should think about different scenarios. We should, as a tester, we should put ourselves in the shoes of our client. We should think how client will use it. So in this way, it is creative and very exciting activity. So we that's why we do human eyes on our product. So in a robotic way, testing same test run again and again will not able to find new defects. So as a tester, we should also focus on what kind of issues developer usually find, what mistakes they usually do, and we should give that attention to also. And principle 6 was testing is context dependent. So we have different kind of applications. Testing is done different in different contexts. So different software are tested with different strategy. We have safety critical application. So in this case, our testing strategy will be different. We should approach different to our safety critical application. Whereas if application is e-commerce website, then our testing approach will be different. So testing is context dependent. We should keep the context, in which context we are going to test. So if the application is safety critical application, if we are testing robots which will be in Mars, then definitely we should give extra attention. We should use formal methods. All the techniques and approaches will be different when application is from different domain. So principle 7 is absence of error fallacy. This principle says meeting the requirement is equally important. So finding and fixing defect does not help if the system build does not fulfill the user need and expectations. So if system is built without keeping the client context in mind, then definitely that will be useless for our client. So requirement should be met. So our first focus should be on requirement gathering. They should be properly documented. And these are all 7 principles which I have discussed with you. Now it's time to discuss about the test process. As I have in the test process, we have test planning. We plan the test. So we monitor the test cases. We do test analysis. We do test design. We do test implementation, test execution, and test completion. So these are very important activities in testing. So every test should be documented, should be planned, should be monitored, should be analyzed, and should be properly designed, implemented, and executed in given environment. And after the test is completed, we should document, we should complete the activities, we should give the reports, and we should analyze how we can improve the process. In test planning, we have test strategy or broader. We have project test plan. From project test plan, we have test strategy. Then we plan test plan in control. We do analysis. We do implementation. Then we do closure activities. And now let's discuss a little bit detail about the test planning. So in test planning, we have consist of following activities: determine the scope and risk, identify the objective of testing. So in test planning document, we write the scope, we identify the risk, and objective of testing are written in that document. So that document should be living agent. That document should be updated throughout the project. This document should not be just sitting on shelf gathering dust. So in test planning, we define overall approach of testing, what approach will be should, how much resources will be involved, and we do usually schedule test activity, assign resources to that activities, define the amount, detail template for documentation. We select the matrices for monitoring and control. So we should select what matrices will be used, how we can control the planning. So we should, in this document, we should define entry and exit criteria. So we should in this document, test automation is also decided what tool we will use and who are the resources available for test documentation. So next concept is test monitoring and control. After the test planning, we move further towards test monitoring, the process of measuring the progress on project. So these contain the set of formula which calculates any dimensions, test defect coverage, for example, how much coverage is done. So in test execution rate, this one following is a test execution rate. This means number of test cases executed over number of test cases planned for execution into 100. This is formula for test execution rate. So test control involves taking actions necessary to meet the objective of test. Then we have test analysis. In test analysis, following major activities are performed. Analysis the test bases. So test bases are those documents which are basis for further analysis. For example, requirement document is test basis for our design. So the requirement documents are test basis for user acceptance tests. So test basis is information needed in order to start the test analysis to create our test cases. So evaluating the test basis and test item to identify defects of various types such as ambiguous omissions, inconsistencies, inaccuracies, etc. So it identifies feature and set of feature to be tested. In test analysis, we define a prioritized test condition for each feature based on analysis of test basis. So considering functional, non-functional, structural characteristics, other business and technical factors and level of risk. Then we have test design. Test design includes the following major activities: designing and prioritizing test cases. So we design the test cases. Test cases should be properly designed. So our application should be properly designed. Identify necessary test data and support to test condition and test cases. So designing the test environment, identify required infrastructure and tool. So in this, we usually identify which environment our test cases will be run. We have in our mind, if you have what environment our test cases will be done, then we will define high quality test cases. It creates bidirectional traceability between test basis and test cases. Then we have test implementation. Test implementation includes following activities: developing and prioritizing test procedure and potentially creating automated test scripts, and creating test suite from test procedure, if any. Test suites are collection of test cases, and test suites are prepared, and especially these are in automated scripts. So arranging the test suite within a test execution schedule is a way that results in efficient test execution. So building the test environment, including potentially test harness, service virtualization, simulator and other infrastructure items, and verifying that everything needed has been set up correctly. So preparing test data and ensuring it is properly loaded into test environment, verifying and updating bidirectional traceability between the test basis and test conditions. So test case, test procedure and test suites. In test execution, we execute our test cases, and so in this case we are following activities: recording the ID, version of the test items, and test tools and testware. So we execute tests either manually or by using execution tool. In both cases, where you compare actual result with expected result, and there is an issue is logged into defect tracking report, for example Jira, Bugzilla, so on. So analyze anomalies to establish their likelihood. Causes failures may occur and these failures are reported. So logging the outcome of test execution, there are pass, fail and break. So these reported issues should be, it would take an action on reported test activity as the result of action taken of any anomaly or part of plain testing, execution of corrected tests, confirmation testing and regression testing. So in this case, after test execution, we should identify whether we should do regression testing to make sure that no other modules are affected due to this change. At the end, we have test completion, so checking whether all defect reports are closed, change request is log, and so all the closure activities are performed in this step. So creating test summary report to be communicating to stakeholders, right, finalizing the archiving of test environment, test data and test infrastructure and other test fare for later reuse. Handed over the test fare to the maintenance team for further actions. So it analyzes lessons from completed test activities to determine change needed for future iteration, release or projects. So lesson learned should be analyzed and reported. So using the information gathered to improve test process maturity. So at the end, we should do critical analysis, what went wrong, how we can improve it. So at the end, we can improve our process. So it is time to discuss about the psychology, human psychology and testing. So the testing in psychologically speaking, testing is destructive activity. Testers and developers usually have different mindset. Testers have constructive mindset, they construct, they develop and they look things in from different perspective. So as a quality assurance, they are trained by differently. So they use destructive approaches, they try to break the application, they have different mindset, and professionally they sometimes clashes with each other. They can be harsh arguments with each other due to these professional. So in this regard, we should be professional. We should not take these things as personal. We should convince if there is issue. We should convince. We should reproduce it as a tester, as a quality assurance person. Is it our responsibility to report the bug in proper way? Steps to reproduce should be written, and we should give the screenshot, error log, and we should give video. We should make the video so they can easily reproduce the bug. Their independence testing, for example, we have level of independent testers. Usually we can divide into 4 categories, 4 levels. Level 1 is test designed by person who wrote the software and test. This can be a developer who writes the application. You can write the test cases, who writes the test case in this way. And test designed by another person, that can be his or her own colleague. So test designed by person from different organization group or test specialists. Usually in the companies we have separate QA team which does the testing, and other we have test designed by person from different organization and company. Usually it is third party which conducts testing. So we have these 4 levels. In the testing throughout the software life cycle, testing involved through the software development life cycle. So I will discuss about software development models, test level, test type, and some maintenance testing. So when we talk about software development models, we have sequential development model, which describes the software development process as linear sequential flow or activities. On the other hand, we have incremental development model, which involves established requirement, designing, building and test the system in pieces, which means that the software features grow incrementally. So we have third development model, which is iterative development model. In iterative development occurs when group of features are specified, designed, built and tested together in a series of cycles, often of fixed duration. Here you can see very V model. In V model we have a requirement, business requirements, then we have system requirement, then we have architectural design, then we have detailed design. If you look at left hand side, you can know this goes like waterfall model, but it is not exact waterfall model. You can know in the right hand side we have during business requirement we usually do acceptance testing, and in each corresponding development activity there is testing activity. In system requirement we have system testing, we have architectural design, we have integration testing, and detailed design we have component testing. So in unit testing, in code we do usually unit testing. So this model is very simple, very basic to explain that in every development activity there should be corresponding testing activity. So this way we can improve our product. We have iterative development model, for example rational unified process model. In this rational unified process, each iteration tend to be relatively long, for example 2 to 3 months, whereas in Scrum, which is very famous, and each iterations tend to relatively short, in hours, days or few weeks. Usually we have 1 to 4 weeks of iteration, and the features increments are corresponding small, such as few enhancements or 2 or 3 new features. On the other hand, we have Kanban, which is implemented with or without fixed length iterations. These are example of iterative development model. We have spiral model, which involves creating experimental increments. So let's discuss a little bit about Scrum framework. In Agile, we have product backlog. Overall product has backlog items. Then backlog items are selected for our sprint. So Scrum Master product owner prioritizes the backlog items and add it into sprint. The sprint can be 1, 2, 3 or 4 weeks durations, depending upon the team and company. So tasks are breakout and sprint backlog is prepared. You have a daily sprint meeting, and in this 15 minutes meeting, teams get together and discusses what they have done last, what they are doing today, and what will do. So these are discussions are done. In this sprint planning, Scrum Master is very important, which does coaching, and in sprint, at the end of the sprint, we have sprint review, we have finish work, we have sprint retrospective, we usually have sprint demos, and then in this way whole process starts again. We collect other items from product backlog and do sprint planning meetings, and items are given to developer, and they moves in this way to our daily stand-up meeting, and then they do sprint reviews, retrospective. In sprint retrospective, they discuss what went well, what went wrong, and how they can improve, how they can improve this process. So this was little bit introduction about Scrum framework. Let's discuss about test levels. Test levels are a group of test activities that are organized and managed together. We have unit testing, which is usually performed by developers. We have integration testing, we have system testing, and usually integration testing and system testing is performed by testers, and acceptance testing, which is performed by end user or client. So we have test types. A test type, a group of test activities aimed at testing specific characteristics of software system. So objective is evaluating functional quality characteristics such as completeness, correctness, and appropriateness. So in test type, we have evaluating non-functional quality characteristics such as reliability, performance, efficiency, security, compatibility, and usability. In test type, we have functional testing, non-functional testing, structural testing, change-related testing. In change-related testing, we have retesting to confirm that fix was okay and it is not breaking. And in a regression testing, we make sure that other modules are not affected due to this change. So let's discuss all these in little more detail. In functional testing, usually we have testing in black box and white box. We usually use black box testing approaches or white box testing. In black box testing, we don't know the internal structure of the code. We are given the product just to test. And in white box testing, which is usually performed by developers, they have the code and they test it. So it shows the white box mean everything is clear, everything is every code which is written is given to for testing. So in static testing, in contrast to dynamic testing, which requires the execution of software being tested, in static testing static testing is important for safety critical system, for example aviation, medical, and nuclear system. So static analysis is also often incorporated into automated build and delivery system. For example, in agile development, continuous delivery and continuous deployment. In continuous delivery and continuous deployment, we usually do static testing. So static testing is very important. So let's discuss about difficult defects. We have requirement defects, design defects, coding defects, deviation from standards, incorrect interface specifications, and then we have security vulnerabilities, gaps or inaccuracies in test basis testability, for example coverage. So there are categories of test techniques, three categories especially. In ISTQB syllabus we have three categories of test techniques: black box test technique, white box, and experience based. So usually you can see these black box testing as a we considered application as a black box, and different approaches are applied to test. And in white box we have the code. Where in experience based, we rely on tested experience. Common characteristics of experience based test techniques include test condition, test cases, and test data are derived from test bases that may include knowledge and experience of tester, developer, and users, other stakeholders. So this knowledge and experience include expected use of software, its environment, likely defect, and distribution of those defects. So it is very important to do experience based testing. As we have more experience associates, they will be able to find more defects. The international standard ISO IEC IEEE 29119-4 contains description of test techniques and their corresponding coverage measures. So in experience based testing we have error guessing. We guess the error, we usually guess the other what developers usually make mistakes. So error guessing is applied. This comes from experience. We have checklist base. We prepare the checklist and we usually do testing. And we have exploratory testing. So exploratory testing is very interesting and a very challenging task and a very exciting testing technique. So let's discover black box testing. In black box testing we have equivalence partitioning, boundary value analysis, decision table testing, state transition testing, and use case testing. I will discuss these in little bit detail. In equivalence partitioning, we usually equivalence partitioning or equivalence classes is a software testing technique that divides the input data of software into units into partitions of equivalence data. For example, in test cases are designed to cover each partition at least once. In equivalence partitioning, we divide the data into partitions. Valid values are valid, we have valid values, invalid values. Valid values are those which system accept. Invalid partitions are those in which we reject. Invalid values are values that should be rejected by component or system. So each value must belong to one or only one equivalence partition. To achieve 100% coverage with this technique, test cases must cover all identified partitions. Here you can see in image we have equivalence partitioning. Here we have invalid in the left hand side, and middle we have valid, and in the right hand side we have invalid. You can see invalid are 0 to 5 in partition 1 and valid are 6 to 10 in partition 2. So in partition 2 you can see 6, 7, 8, 9, 10 are valid values. It will test for all test cases present in this partition. So from this we need to run one test case to cover this partition. You know, I have discussed with you 7 testing principle, which was the exhaustive testing is impossible. For in this case we should pick one value from this partition, one value from invalid, one from valid, one in. So in this case if we run the 3 test cases we can cover all these. So in partition 3 we have invalid, we have 11, 12, 13 and 14. Now let's discuss about equivalence partitioning. Here you can see an example. We have integer field shall contains value between 1 to 15. So we have integer in 1 to 15. Now applying equivalence partitioning, what is the minimum number of test cases required for maximum coverage? So how many test cases are required to achieve maximum coverage? In this case you can see 3. Answer would be 3. We have 1 to 15 valid partition, and less than 1 and greater than 16, these are invalid. So these 3 test cases are required to cover. So this technique we can overcome the problem which we discuss about the exhaustive testing is impossible. So we have boundary value analysis. Boundary value analysis is an extension of equivalence partitioning. Boundary value, as you can see, we identify the boundaries. So mostly issues occur on the boundaries. We should do boundary analysis value. We should write the test case to test the boundaries. Boundary value analysis can be applied at all test level. So boundary value can be applied in unit level, integration, system acceptance testing. So this technique is usually used to test techniques that call for range of numbers including dates and time. So here dates, if we have dates fields and time fields, we usually do boundary value analysis. As you can see in this example, we have age field which accepts the value from 18 to 56. So in this case we have invalid, less than 18, 17 is invalid. Then we have 18, then we have valid values which are in middle, we have invalid. So greater than 56 are invalid. So in this case, then what will the boundary? We have 3 equivalence partitions. We have boundaries are 17, 18, 56 and 57. So we need to test all these boundaries to make sure that everything is working. Usually we do not have time to test each and every value. So for example in name field it accepts characters length 16 is 6 to 12. So 6 to 12 are valid, and greater than 12 are invalid, and less than 6 are invalid. So boundaries are 5, 6 and 11 and 12, 12, 13. So these are the boundary value. Let's take an example. A text field in application accepts input as the age of user. Here the values allowed to be accepted if the field is between 18 to 30 years, inclusive of both the values. By applying boundary value, what is the minimum number of test cases required for maximum coverage? In this case, we need to answer what is the minimum number of test cases required for maximum coverage. How many test cases are required? 4, because we need one test case for 17, 18, 30 and 31. So we need 4 test cases. We can do maximum coverage. So you can see here we have 18 to 30 valid and others are invalid. So in this example, a text field in application accepts input as the age of user. Here the value allowed to be accepted by the field is between 18 to 30 years, inclusive of both the values. Based on the boundary values which is the given option consists of valid collection of boundary values. Here you can see valid collection of boundary values are 17, 18, 30 and 31. So next is a text field in application accepts input at the age of user. Here the value allowed to be accepted by the field is between 18 to 30, inclusive both the values. By applying equivalence, partitioning and boundary values, which of the given option consists of valid boundary values and invalid equivalence values. Here you can see the answer 18, 30 and 25. Here we have equivalence partitioning. We have equivalence partitioning. We have invalid valid partitions. We do boundary analysis. So valid boundary value analysis and valid equivalence values will be 18, 30 and 25. Now let's discuss about decision table testing. Decision tables are a good way to record complex business rules that the system must implement. When creating decision table, a tester identifies conditions of an input and the resulting actions of an output of the system. It may be applied to all situations in which the behavioral system depends upon the combination of conditions at any test level. It also helps in finding any gap in the requirement. Decisions tables capture system requirement that contains logical conditions. In decision tables, we have the left side, we have conditions 1, 2, 3 and so on. We have actions, and on these condition actions are performed. We have test case 1, then can be true and false, test case 2, that can be true and false, test case 3 and that can be true and false, and so on. Here in an example in decision table testing, what is expected result of each of the following test cases? A Citibank card member holding a silver room. As you can see from tables, we have rule 1, rule 2, rule 3 and rule 4, and we have conditions, then we have actions. A Citibank card member holding a silver room. We have in rule 2 Citi card member holding a silver room. Here you can see we have in rule 1, and B option is non-Citibank member holding a platinum rule. We have in rule 4 non-Citibank member. Here we have no holding a platinum room. So in this case we have rule 4. So here we have this option A, offer upgrade to gold. Yes, rule 1, yes, and B, don't offer any upgrade. So this one red highlighted is correct option. So another option, given the following decision table, which are the following test cases and expected result is valid. So what is valid? Here you can see the conditions and actions, rules, rule 1, rule 2, rule 3 and rule 4. 23 years old insurance class, 23 years old in insurance class A. Here you can see we have in rule 2 and we have class A or B, and premium is 90, yes, and excess is 2500, yes. this one is correct, all others are invalid. So let's discuss about state transition testing. In state transition testing, used for menu-based application, is widely used with the embedded software industry. In the embedded software industry, we have states true or false, yes and no. So in these states actions are performed. And this technique is usually suitable for modeling a business scenario having specific states or screen navigation. So the concept of state is abstract. It may represent a few lines of code or entire business process. In state transition, we concept the guard condition. If the same event can result into two or more different transitions from the same state, that event may be specified as guard condition. So in state, we have state, for example, from ice to vapor, water, from water to vapor. So you know, we cannot have directly from ice to vapor. Ice when melted becomes water, and water then heated becomes vapor. So these are valid from A to B, B and then B to C, C to D as valid. So ice to vapor, these are invalid transitions. Here is an example based on given state transition, which of the following is test case is invalid. As you can see, we have from false to on to false, on to fault, but we don't have fault to on, so this is invalid. Then we have use case testing. In the use case, we have actor system. So each use case specifies some behavior that the system can perform in collaboration with one or more actors. So interactions may be represented graphically by workflow, activity diagram as business process. Here you can see online shopping system. We have customer interacts with the system, and it can log in authenticates the user, and then it can view the item, it can make purchases, and system also identifies the provider, and if it does the checkout, then credit payment service are called, and then PayPal, for example, PayPal credit card information, the amount is deducted from those systems. So in use case testing, here is another example. We have actor and system. For example, in ATM case, ATM machine is a system, and person who is doing interaction with ATM machine is the actor. So let's discuss main success scenarios. For example, a person insert the card, so it system which is ATM validates the pin, then a actor inserts the pin and system validates that pin, and system allows access to account. Extensions are card not valid, so system displays the message and rejects the card. And other can be pin is not valid, system displays message and asks for retry 2 times. If 3 times wrong pin is entered, then system should eat the card and should exit. So here is an example. You can see which of the following statement about the benefit of deriving test cases from use case are true and which are false. Here we have A, D are true and B and C are false. For example, deriving test cases from use cases helpful for system and acceptance testing, and deriving test cases from use cases helpful for integration testing. So A and D are true and B and C are false. In white box testing, I have discussed about the black box testing. So in white box testing, we have statement testing and decision testing. So in statement testing, we test the statements. Statement testing exercises executable statement of the code. See, coverage is measured by number of statements executed by the test divided by total number of executable statements in the test subject, normally expressed as percentage. So statement testing or statement coverage tests the statement of a given fragment of the code, whereas decision testing or decision coverage tests the decision made with the given fragment of code. So decision testing also known as branch testing or branch coverage. decision testing is stronger than statement testing. So 100% decision coverage guarantees 100% statement coverage, but not vice versa. Here we have example statement testing and coverage. We have code and flowchart. We have code read A, read B. If A greater than B, then print A is bigger, else print B is bigger, and if. This is a very simple code just to illustrate. In statement coverage we have two, and tip is, for example, number of else plus 1. So statement coverage can be number of else plus 1. We have 1 else plus 1 2. So statement testing statement coverage is 2. So here another, we have another example what the minimum number of test cases required for 100% coverage. In this case we need 2 test cases to do 100% test coverage. Here we have another example. Here you can see read A. If A is greater than 0, then if A is equal to 2, then print key, and if. So in this case statement coverage is 1. The tip for unnested conditions is number of else. In this case number of else, here we have 1. So statement coverage in this case is 1. So statement testing in coverage, let's discuss this code. As you can see, in this case we have nested conditions. In this case we have number of else plus 1. We have statement coverage in this case is 2. Here is another example. In this case you can see unnested conditions, we have number of else. In this case statement coverage is 2. So here is a helpful tip for doing statement testing in coverage. So tip for unnested condition, statement coverage is number of else, and tip for unnested condition, statement coverage number of else plus 1. So statement testing coverage, here you can see the example. For given fragment of the code, following path test cases has been executed, what statement coverage is achieved. So in this case we have test 1 A, B, C, A, B and C. Then test 2 is A, D, A, D, A, B, sorry, A, B, D, D, G and H. In this case we have 75%. So in this case statements are, these are statements which are circle, and you can see the statement coverage is number of statements executed over total number of statements. Here we have 6 number of statement executed were 6, 1 2 3 4 5 and 6, A, B, C, D, G, H, and total number of statement were 8. Here we have total number of statement A, B, C, D, F, G, H, I, and into 100 is 75%. Then we have decision testing and coverage. Decision testing or decision coverage test the decision made within the given fragment of code. So decision testing, also known as branch testing or branch coverage. Decision testing is stronger than statement testing. 100% decision coverage guarantees 100% statement coverage, but not vice versa. Here you can see the decision testing and coverage. We have read A, read B. If A greater than B, then print A is bigger, else print B is bigger, and if. We have decision coverage too. In this case, it's very simple. You can see the flow chart. So you can see the other examples. Here are decision testing and coverage. You can see the tip for unnested condition. Decision coverage is 2 regardless of number of ifs. Tip for unnested condition, decision coverage is a number of if plus 1. So let's discuss this example. For a given fragment of code, following path test cases have executed, what decision coverage is achieved. In decision coverage, test 1 we have A, B, C, and test 2 have A, B, D, G, H. So in this case decision coverage is number of branch executed over total number of branches into 100. So how many branches? 5 executed, A, B, C, D, G and H over 8. Total number of branches, sorry, these are branches. Here you can see the arrows. These arrows are branches. Total of 5 executed, 1 2 3 4 and 5, and total branches are 8. You can see 1 from A to B is 1, B to C is one branch and B to D is one branch. In this case we have 1 2 3 4 5 6 7 and 8 into 100 is 62%. So thanks very much. If you have any questions, you can feel free to ask me. I hope you find helpful. Thank you. Bye.